Hey guys, I wanted to give you a couple of examples of how to solve separable differential equations like this one. We have dy dt is equal to k times y, where k is some constant. One of the reasons why these differential equations are called separable is it's possible to separate the equation so that all of the terms involving y are on one side and everything else is on the other. If we divide both sides by y and multiply through by dt, we end up with 1 over y dy equals the constant k times dt. So all of the y terms are by themselves on the left side, and anything involving t is on the right side. Okay, the next step then, we want to integrate each side of this equation. So we're going to evaluate an integral from we're going to evaluate the integral 1 over y dy, and we're also going to evaluate the integral k times dt. We're integrating with respect to y, so we're going to get the natural log of the absolute value of y plus some constant, which I've called c1. And on the right side, since the constant can be factored out or taken out of the integral, we end up with kt plus some other constant, which I've called c2. Okay, the final step is to solve the differential equation, which means you need to write y as a function of x, so we're going to have to solve this for y. You can move the first constant over, and what I'm going to do just to make things easier is, since both of these constants are arbitrary, I'm going to rename this c2 minus c1 as c, and write this as natural log of absolute value of y equals kt plus c. In order to clear out the natural log and have y only, we're going to need to exponentiate, which means I'm going to take e to each side. So e to the natural log of y and e to the kt plus c power. And I end up with the absolute value of y equals e to the kt plus c. And you'll need a note on here that e to any power is positive for all x. So it doesn't matter what power you raise e to, you're always going to get a positive number. So we can drop the absolute values. And our final answer is y equals e to the kt plus c.